And now welcome to this week's edition of Where Did the Road Go?
And this week on the show, from Sacred Geometry International, we have Randall Carlson. And if you have any questions for Randall, go to our chat room at www.wheredidtheroadgo.com, and I will pass them on as we talk. Links to Sacred Geometry International can be found there as well. Randall, are you with us?
I'm there. I'm here, Zariah.
All right. And can you tell us a little bit about Sacred Geometry International?
Well, Sacred Geometry International was essentially established to make people aware of the enormous amount of cutting-edge research that's being done into various arcane traditions of knowledge. And using sacred geometry kind of is the focus for the thing, the matrix from which to understand it, because that's been part of my background is an interest stems from being a builder. I got interested in geometry very early on really in the early 70s, and then I began, again from the perspective of a builder, I became very interested in how ancient peoples around the world built things, the technologies they used, the design principles they use, and that's kind of what led me initially into the study of geometry, both as a practical art that I could use in my own building projects, but also as a key to understanding some of the motives of the ancient builders. And then I quickly discovered that it could be taken literally as a symbolic language, and my studies kind of went from there. I guess early on I was influenced by Buckminster Fuller, largely, as a lot of people were back in the 60s and the 70s. Built a couple of geodesic domes and had that experience in the early 70s. And just my studies sort of progressed through meeting teachers like Keith Critchlow, who is a British architect who was very instrumental in teaching people about the principles of sacred geometry, reading the works of John Michel, Robert Lawler, some of the getting into the study of the Kabbalah and realizing that there was an important geometric component to that, then realizing that a lot of the esoteric traditions utilized geometry as a symbolic language, then realizing that language itself had a geological underpinning to it that became one of the principal working methods of the Kabbalists, and that is translating words and names and phrases out of sacred writings into numbers, and then relating those numbers to each other by geometrical proportions. So I started teaching the subject of sacred geometry in the 1980s, early 1980s, and have been doing it off and on ever since, and carrying on my researches into that subject. I've always had an interest and fascination in earth science and astronomy, and quickly came to realize that many of the proportions, the sacred proportions that one finds embedded in architecture, the architecture of old, embody proportions that are found, of course, throughout the natural world and in the astronomical realm. And so one can find built into many of the sacred structures proportions that are derived from the study of astronomical relationships. And when I talk about astronomical relationships, I'm talking not only about spatial relationships, for example, the sizes and distances of the planets, but I'm also talking about temporal relationships in the sense that of orbital periods and rotational periods and so on. And one of the things that led me in, I guess when I was made my first trip to Europe in 1988, I believe it was, and began to visit cathedrals in an attempt to decode some of the symbolism of the Gothic cathedrals. One of the most prevalent images that I found was the references to the Great Ear. And so I got interested in this concept of the ancient model of time, which essentially is cyclical, as contrasted with our more modern view of time, which is linear, that there was some starting point or some definite end point. But in the ancient models, it was cyclical. And the cycles unfolded according to a certain tempo, And this tempo was governed by the same proportions that one finds in the study of sacred geometry. Then from there, you could say it was led into the study of the geological evidence, because the geology, the rocks of the earth, actually carry the imprints of various of these cosmic changes. And as I learned more about that, I realized that the tempo that scientific models were presenting to us seemed to be governed again by the same ratios that was one was finding throughout these other domains of information. So that led me into my current research, which is essentially looking at the temporal periodicities and the timing of the great global Earth changes, and have discovered there's a strong correlation between archaic models and modern scientific models, which strikes me as a fairly important thing for people to understand these days. And having communicated and talked to many, many geologists over the last 20 years or so, I've realized that not that many of them are aware of the fact that there's this whole corpus of information that we've inherited from the ancient world that has direct relevance to our own quest to understand whether there are the timing and tempo of the great changes. You see, when I came of age, the model of Earth change was strictly uniform. Even it was called uniformitarianism, and that was the model that prevailed for most of the 20th century. Now, if you go back to the early days of Earth science, early 19th centuries, most of the early 19th century geologists, although they weren't really called geologists back then, but the natural philosophers and the researchers and so on, they, for the most part, looked at various evidence within the Earth itself and had concluded that there had been great catastrophes. As the 19th century progressed, that idea fell out of favor and was replaced by what we could call Lyellian gradualism, which was named after Charles Lyell, who was one of the, along with James Hutton and James Playfair, who basically expounded this idea that all Earth change could be understood by reference to things we see going on today, and to assume that there had been processes on a scale beyond what we have observed today was considered to be unscientific. And so we see that in the early days of geology, most of the founding fathers of geology were catastrophists who believed that Earth had been shaped through great catastrophes. As that fell out of favor and we come into the 20th century, we see that paradigm almost completely replaced by the uniformitarian or the gradualistic paradigm, and that more or less became the dominant belief system, and anybody who deviated from that was more or less branded a heretic or somebody out on the fringe. However, what's happened, though, is particularly the last quarter of the 20th century, the evidence for catastrophes in Earth history became so overwhelming that we now see what I consider a resurgence of catastrophism, or a new catastrophism. And what I'm trying to do with it is to show that those who are now recognizing that Earth has gone through two modes of change, the gradualistic change that has prevailed basically through historic times and through modern times, is frequently punctuated by catastrophic change, short-lived, concentrated, intense change, and that our awareness and understanding of that mode of change can be immeasurably enhanced by reference to much of the ancient writings and ancient traditions and so forth that have generally just been taken as pure myth. But now we realize that behind these myths, there are records of real events.
Okay, wow. So sacred geometry in itself is these numbers being recorded in these buildings and these structures and stuff, and they're pretty consistent no matter where you go in the world, aren't they?
See, I lost you.
That's okay. The sacred geometry
Yes.
is these numbers being embedded into these buildings, into these structures and such, and they're pretty consistent wherever you go in the world, aren't they?
Yes.
And these are
Yes,
very
yeah.
ancient structures. We're not talking about stuff that was built recently.
No, we're generally talking about structures that are ancient, although they come down as recently as the Middle Ages, because we certainly find the symbolism embedded in the Gothic cathedrals and structures that were built in Southeast Asia, such as Angkor Wat, which embodies the cycles as they were basically expounded upon in the Vedas, in the Vedic tradition. So the proportions that one finds in the yugas, which are the term for the time cycles in the Vedas, are built into the dimensions of the ground plan of Angkor Wat, as an example. Also, Angkor Thom is another one nearby there that reflects these numbers. You can also find the same thing expressed in the last great wave of architectural activity in Mesoamerica, pre-Columbian Mesoamerica, 11th, 12th, 13th century.
Why do you... Go ahead.
Go ahead.
Why do you think these numbers were so important that they had to embed them in these structures?
Well, for two reasons. Number one, I think that the numbers themselves reflect fundamental proportions that seem to be germane throughout all of creation. So in order to understand creation and to try to reflect their model of creation, which was basically the work of a divine architect, if you will, the motive was to try to create structures that reflected this higher order as they perceived it and understood it. Secondly, like as in the case of the Angkor Wat and the Vedic traditions of time, all of these concepts, whether we're talking about the Mayans or the ancient Indo-Aryans or the megalithic builders of the British Isles, the ancient Egyptians, we find the same idea that you had these great cycles, and that the termination of these cycles were always involved catastrophic upheavals. And so I think that would be a very pragmatic reason for attempting to...
as a warning.
As a warning, yes, exactly. So I think there's a dual reason, both from the creative end of it, but also from the destructive end of it, because you have this dualism going on there, in that our world, as we inhabit it, manifests these relationships. We could call them they were referred to by one researcher, by the name of J. Hambidge, back in the early 20th century, as dynamic symmetry. And essentially these relationships that can be the square root of 2, the square root of 3, the square root of 5, the phi number or the golden number, several others, these were found ubiquitously throughout the natural order. They're also found prevalent throughout all of the ancient sacred architecture. It seems to be one of the criteria for defining what constitutes sacred architecture. Seems to be this presence, this ubiquitous presence of this geometry. But built into this, like when you walk up to Chartres Cathedral, if you walk through the western portal there, it's called the Portal of Judgment, and you see an effigy of Christ in glory enclosed within the vesica. The vesica, or the vesica piscis, is the fundamental form of sacred geometry, or just Euclidean geometry in general, and it's the form out of which all other form emerges. So it has this feminine symbolism to it, in that it could be construed as a womb, because out of this womb emerges all of the forms and patterns and figures of geometry. And it's also thought of just as a womb, as a gateway between two domains or two realms. The vesica was considered to be a gateway between two realms. And so we have Christ in majesty seated in the vesica, which represents the gateway between two worlds. But surrounding that are the four creatures that we find, universally in some form or another, representing the four fixed signs of the Zodiac. So you see, if you just Google Chartres Cathedral, Portal of Judgment, I'm sure you'll get images of this, and you'll see a bull, a lion, an eagle, and a man representing, or rather, in this case, it's an angel. The bull being Taurus, the lion being Leo, the eagle representing Scorpio, because Aquila, the eagle, rises at the same time as the scorpion, and then the angel representing Aquarius. And what this actually represents is at least in my opinion, is that it represents the four fixed signs, or the four seasons, if you will, of the great year cycle, which is based on the precessional motion of the Earth's axis. And it does seem like ancient peoples were very, very keyed in on tracking this very, very subtle motion, which is, you could think of as the Earth's third motion. Its primary motion, obviously, is the rotation on its axis. The secondary motion is its yearly revolution about the sun. And these are obvious, because all of us, our lives are basically governed by these cycles. The day-night cycle, the yearly cycle. The yearly cycle may be less so now, but certainly agricultural people and for most people in the world up to, the 20th century, their lives were heavily governed by the yearly cycle and the change of the seasons. Well, the idea, I think, here was that many of the ancient initiates were very much interested in the larger framework, the larger picture of things. And so, all of these structures, they have an astronomical component. There's a whole science that's emerged in the last 30 or 40 years called archaeoastronomy, which is looking at the astronomy that's embedded in these structures. So they not only encode geometric relationships, they also encode astronomical relationships. And so you look at Stonehenge being the most salient example. You would look at Stonehenge, and from the altar stone, looking out through the aperture of the sarsen stone ring over the heel stone, you see that there's this alignment built in. And this alignment marks the midsummer solstice. And you see there are 4 points within the annual cycle. Just, you could think of it as analogous between the annual cycle and the daily cycle. Just as you have dawn, high noon, dusk, and midnight in the daily cycle, you have spring, summer, winter, and fall in the annual cycle. But then in the great year cycle, you also have 4 seasons. Now, the belief was, at least from my reading into commentaries on myths and reading the myths themselves and so forth, is that the belief is that there would be, within that great cycle, there would be points of discontinuity, if you will. These points were like punctuation marks within to borrow the phrase from Stephen Jay Gould, the paleontologist who coined the phrase punctuated equilibrium to describe the progression of life on Earth. Essentially, what he was doing was just giving a new name to an ancient concept, that the normal pace of things is interrupted from time to time. Enormous changes happen within these windows, and then things settle out, and there's a new order of things, a new order of nature, a new order of the world, a new order of the ages, if you will. And in this model of the Great Year that's represented, I believe, on the portal of Sharp, you have the 4 fixed signs. If you go back and now you begin to reconstruct the global change based on purely scientific models with no reference whatsoever to archaic models, what you find is that there's an extraordinary correlation. We can go back and we find that there's actually what was called the Baling-Alarod Younger Dryas transition, which is now dated at 12,900 years ago. And this is precisely half of a precessional cycle ago. So if we go back and if we take the great cosmic hand, the hand of the cosmic clock, which is the equinoctial line, and back it up 12,900 years ago, the vernal equinox would be standing right on the cusp of Virgo-Leo. And this is one of the key points within these archaic models. And now science has demonstrated that there was an extraordinary cataclysmic event that occurred pretty much right on that line. And it was this that began this basically 1,500 to 2,000 year shift of the planet out of the grip of the Great Ice Age or Glacial Age into this interglacial age that we're in now. And very few people realize or have ever really thought about how extreme and how the full extent of the global changes that occurred through this transition in the age of Leo, which would have essentially lasted from about 10,800 to about 13,000 years ago. But prior to this transition, we had an ice cap bigger than the one that now covers the South Pole, and it reached from the Atlantic to the Pacific and from the northern United States up to the Arctic Circle and may have been up to 2 miles thick. So the entire region where you are now, where you are in Ithaca, was actually still under the ice sheet. You were near the southern margin of the ice sheet, but you were still under an ice sheet. South of where you were now, for a belt reaching across most of Ohio, would have been tundra, Ohio and Pennsylvania. Sea levels globally, for example, were about 400 feet lower. Well, you drop sea levels worldwide by 400 feet, and you've exposed most of the planet's continental shelves. And so then when you in the Ice Age, you are essentially releasing all of that seawater that has been locked up for millennia in the ice sheet, and it flows back into the oceans and raises sea levels and drowns the continental shelves. So you go through this transition where you have, it's estimated that around 7 million square miles of land was locked up under ice, and this is both in North America and Northwestern Europe, as well as enlarged ice caps on Greenland. So what happened with the end of the Ice Age is the ice melted away and it freed up 7 million square miles of land, surface, real estate, but at the same time it drowned a comparable amount. What's interesting, though, that if you found yourself suddenly transported back 14, 15,000 years ago, and of course people did live then, we lived much longer than that, we lived many tens of thousands of years ago, we modern humans, but one of the prime habitable areas of the planet would have been, on the coastlines of the world, and also at the mouths of rivers. And of course, those areas are all now under 300 to 400 feet of water. So I confidently make the prediction that many of our advances in archaeology are going to come from marine archaeology and the discovery, to whatever extent these remains still exist, of human habitation along ancient coastlines going back 14, 15, maybe 20,000 years ago and longer.
So was that the last great destruction, do you think, the end of the last ice age?
Well, I think it's the end of the last ice age. If as our barometer of change, if we look at species loss, which is basically a function of habitat loss, there was a great extinction, a mass extinction of species that took place at the end of the last ice age, usually referred to as the mega mammals. Mm-hmm. And this includes, the woolly mammoths and the mastodons and the giant ground sloths, the saber-toothed cats, the giant beavers, the cave bears. I mean, literally, there was about, depending on how you divide them up, about 120 to 130 species of large mammal that went extinct during this age of Leo time, between about 10,800 and 13,000 years ago. Now, if you do a census of modern animals, and when we define a mega mammal as a mammal that weighs more than about 40 kilograms, which is about 100 pounds. So if we were to do a census of all the modern day mammals that weigh over 100 pounds, there are about 130 to 140 species globally, worldwide. And this is, of course, all of the familiar ones that we know, the lions and the tigers and the bears and the moose and the deer and the wolves and the caribou and all of these. Sum them all up, we've got about, let's say, roughly 130 species. Okay, well, that's about the same number that went extinct globally 13,000 years ago. And if we push the clock back to 15,000 years ago, we see that the number of species of large mammals was almost double what it now is. So if we were going to eliminate an equivalent number of species from the planet today, as we lost 13,000 years ago, we basically wouldn't have any animals left over 100 pounds in body weight. So that kind of gives you an idea of the severity of it. In order to find an equivalent extinction event, we have to go back to what's called the Hemp Hillian event, which actually dates to about 5 million years ago. So interestingly, this event that occurred between, say, around 12 to 13,000 years ago, I think in terms of species loss, and again, that being a function of habitat loss, has been the most severe in 5 million years. Now, there have been destructions since then. I think the evidence is emerging that there have been some pretty extraordinary destructions, even within what's called the Holocene, which is the interglacial epoch that we're in now. The glacial epoch is usually called the Pleistocene, and most of the dates given for the Pleistocene place it at beginning around 2.6 million years ago, right? 2,600,000 years ago. And what defines the Pleistocene, in contrast to the previous epoch, the Pliocene, is this onset of this cyclical swinging back and forth of the planet between glacial and interglacial ages. And some estimates have placed the number of oscillations up to 30 or 40 in the last 2.5 million years. That maybe 40 times the planet has shifted into a glacial age and shifted back out again. The previous Pliocene age was basically marked by a long period of stability and warmth and high sea levels without this oscillating climate. So there was something that changed, something that affected a very fundamental change in the way the planet operates around 2.5 million years ago. And my suspicion would be that whatever it was extraterrestrial. That what we're seeing in Earth is a response to a change in the extraterrestrial environment. So we come through 2.5 million years of these oscillating glacial interglacial ages, and now we're in what's called the Holocene, the Modern Age, which is an interglacial age or interglacial epoch, and it's no more than 9,000 or 10,000 years long. As the record is now being reconstructed of the last, let's say, 500,000 years, going back where we can reconstruct it with a high degree of accuracy, mostly based upon ice cores extracted from Greenland and Antarctica, but also from sea, drill cores taken from the sea bottom, from stalactites in caves, from palynological studies, which is the studies of pollen. I mean, many different kinds of things by which we can map out the changes in vegetational patterns as a response to climate change and so on. What we discover is in its own way a bit sobering, and that is the periods of interglacial warmth and relative climate stability have been very short duration. In fact, you could say that the current Holocene, the one we're in now, out of the last, at least based on the Greenland ice cores, which gives us a high degree of resolution back to about 250,000 years, the Holocene, the present period of relative warmth and stable climate, is the longest period equivalent to that of the last 250,000 years. No, in other words, there's been no period that has lasted typically longer than 6,000 or 8,000 years before catastrophe has entered the scene. And we've already exceeded that by a couple of millennia. So from that standpoint, maybe we shouldn't take things for granted.
It's very, very true. All right, I got to take a quick break here. We'll be back in 45 seconds with Randall Carlson.
Okay.
The opinions expressed by the host and guests on Where Did the Road Go are their own and do not represent those of WVBR or its management. Join us on the web at wheredidtheroadgo.com, where you can send us questions for our live guests via email or the live chat room. You can also check out our upcoming schedule, blog, link section, book reviews, videos, and links to our Twitter, Facebook, iTunes, and much more. That's wheredidtheroadgo.com.
And this week we have Randall Carlson, and we've been talking about the cycles of catastrophe. And are you familiar with Robert Schoch's latest work?
Yes, I am. I'm definitely familiar with that. I know Robert fairly well.
What do you think of his theories on the sun ending the last ice age?
Well, I would have a discussion with him about that. It's a very interesting possibility, and I think it's plausible. If you read his book, you see that at the end he does sort of leave the door open, though, to an impact or a series of impact events, which is the explanation I think I would be more inclined to for a number of reasons. But yeah, I mean, I have a great deal of respect for Robert's work, and I've read his book with great interest and would actually like to reread it and follow up some of his sources, which I haven't had a chance to do yet. I certainly think that the mechanism that he invokes is a plausible mechanism, and it's probably been one of the factors as we go. I think probably we could perhaps look at. In fact, interestingly, there are some arcane traditions that would seem to imply that there are significant enough solar changes to invoke responses here in the terrestrial environment. But also, clearly, I think impacts of things from space is to me is the dominant one right now. But certainly also large volcanic events as well certainly can have the capacity to dramatically change the climate.
Now I have heard you talk about how fast the ice caps melted, and you, I believe, said that they melted faster than we can actually explain.
Yes, that's true. Back in the early 70s, you see, initially there was a lot of assumptions made back, let's say, pre-radiocarbon dating, as to the duration of ice sheets and how long it takes them to form, how long it takes them to melt. at the birth of modern Earth science, essentially coincided with the end of what's called the Little Ice Age. And during the Little Ice Age, glaciers globally expanded to their greatest extent in 10,000 years. A lot of people don't know that. So it's important, I always try to, when we start talking about modern climate change, I think it's important we place that into context, that when we talk about, the climate having, how much it's warmed in the last 150 years, we have to realize that we were coming out of a 300 to 400 year cold spell that was the coldest the planet has been in 10,000 years. So, glaciers worldwide grew to their greatest extent since the end of the Great Ice Age. In any case, with the advent of modern geological science, you had observers out essentially who could see the shrinking of the ice caps that had grown throughout the course of the Little Ice Age. And based upon rates of recession that they had actually observed, let me digress for 1 second. It's what they observed through the course of the Little Ice Age and the effects that they saw when the glaciers, for example, grew down out of the Alps into the Jura Valley. They created a whole suite of geomorphological features, creating moraines, creating eskers, erratic boulders. When the ice receded, it left this glacially sculpted terrain in its wake that these astute observers could see firsthand. Well, what they saw was that these features were a smaller scale of these much larger features that they had also been observing, that they weren't able to explain except perhaps by recourse to the Noachian deluge, Noah's flood. Well, in any case, based upon the rates of recession of the ice, of the Little Ice Age, they extrapolated to the assumed rates of recession for the Great Ice Age. And, once they became aware of the full extent of how vast these ice sheets were back 14, 15 to 20,000 years ago, it took a generation or two to come to this awareness of the full extent of the ice, primarily due to the work of Louis Agassiz, who was considered the godfather of glaciology. But they then sort of extrapolated and assumed that you had, perhaps 30, 40, 50,000 years or more, maybe 100,000 years for the planet to go shift into an ice age and shift gears to come out of an ice age. And this is the idea that pretty much prevailed in all of the literature and all of the models up until the 1960s. What changed was the invention of radiocarbon dating. And as radiocarbon dates began to accumulate, it became apparent that the whole process had happened much quicker than anybody had previously imagined. So that, for example, dates started showing up of forests growing in Canada where the ice sheet was, for example, 40,000 years ago. Well, if 40,000 years ago there were forests growing across central Canada, then there obviously wasn't ice there. So right there, that constrained the window in which the ice age event could play out. But so by the early 1970s, enough radiocarbon dates were in hand and enough evidence had come that contradicted these long, slow, drawn-out models that they held a series of conferences, I think, between 1973 and 1975, where they examined the radiocarbon dating and looked at the rates at which the ice had disappeared. And they realized that at, say, roughly 14,000 years ago, the whole ice complex was, for the most part, still intact. By 8,000 years ago to 9,000 years ago, it was gone. So the window to get rid of the ice contracted like by an order of magnitude. So here now you're going from tens of thousands of years to melt away the ice to perhaps 5,000 years. Well, this rate created a problem, see, because number one, you have to have heat in order to melt ice. And so they did some calculations as to the available heat, for example, in Canada today. And Canada today has very cold winters, doesn't it? And as does Ithaca, New York. And I'm from Minnesota, so I remember well shoveling my driveway as a kid growing up. And I think that's one reason I'm in Georgia at the moment. But, nevertheless, come spring, it all melts and goes away, right? It doesn't form glacial ice and eventually become a mile thick, right? Well, you have to literally think of it this way. The onset of an ice age, basically, you have the onset of winter, but then winter doesn't go away for 10,000 or 15,000 years. And then finally, 15,000 years later, you have spring. Well, when the great spring, the great melting came, this was, again, 10 to 12,000 years ago is where the concentration of the melting occurred. So they did these calculations, which essentially were trying to determine how much heat energy would be necessary to melt the ice that fast. And when they calculated the available heat energy in Canada today, the number that they came up with was something on the order of 30,000 years to melt the ice. Because first of all, it's going to melt for those few months during the summer, but then winter's going to come, it's going to cease melting, and presumably even accumulate some, Then summer will come and it's going to melt some more, but the melting will be somewhat greater than the accumulation, and eventually the ice would be gone, right? Well, assuming a process like that, which is extrapolated from what we see going on today, it just didn't work. It was going to require, again, I forgot the exact number, but 25 to 30,000 years. Maybe it was even longer than that. Well, then they said, well, geez, where is the greatest heat energy available on the planet today? And basically it was tropical oceans. So then they redid their models, and with the idea that, let's look at it from the standpoint of the amount of heat energy available at tropical oceans. And what they realized was, even at tropical oceans, it was still going to take nearly 20,000 years to melt the ice. So here you've got this conundrum now, and essentially they called it the energy paradox. This was the term they used for it in the literature. They talked about the energy paradox, and they said, well, there's obviously an error in our data somewhere, so we're going to put it on the shelf and we'll get back to it when we have more information. And basically, they haven't gotten back to it. And if anything has happened in the interim since the early to mid 70s, it's that we've further constrained the window during which the ice melted. In fact, what the Greenland ice cores seem to show now is that there were two things. The Greenland ice cores show that there were two extreme warming events. All right. Also, studies of sea level rise show that there were two what they call CREs. CREs stands for catastrophic rise events. And there were apparently two of these extreme pulses of meltwater influx to the oceans, the global oceans, which they term catastrophic rise events. It appears that these two thermal events recorded in the Greenland ice cores correspond with the CREs, or catastrophic rise events. So in a sense, you had a large bulk of the ice melting over an extremely short period of time. And if we look at the geomorphic effects of that, I think that it's borne out that we have just extreme melting on a scale that's really almost impossible to visualize. I've spent the last 20 years trying to construct scenarios in my own mind. So I've traveled with some of my friends and colleagues over most of North America, looking at the consequences of this catastrophic melting, and essentially have traced it along the southern margin of the ice sheet from the Atlantic Ocean to the Pacific Ocean. That's what brought me up to your area back in 2001 and looking at the origin of the Finger Lakes, which I'm sure, you're at the southern end of Lake Cayuga, right?
Yes. Yeah.
Okay, well, have you ever thought about the origin of that beautiful...
Well, I think the official story is that it was carved out by glaciers, and the remaining ice melted in place, forming the lakes where there were gorges, where the biggest gorges were.
Well, that's the official story, but the official story doesn't really hold up, basically, for the last 20 years. There was work done in the late 80s and early 90s where they did the first seismic reflection profiles of the lakes, basically all of the lakes, but the two most particular that I think they focused on was Cayuga and Seneca, because they're the biggest lakes.
Right.
They correlated the seismic reflection profiles with drill cores that were taken from the bottom. what they discovered, like in the case of Lake Seneca, the bottom, the bedrock, the bottom of the lake itself is sediment. But you take the sediment out, there's 900 feet of sediment. And when you take the sediment out, the bedrock trough that the lake is in is actually 1,000 feet below sea level. And then there's 900 feet of sediment. Well, the thing that shocked the geologists working on this was that with so much sediment, they assumed that if it had been created over a long period of time, that as you went down core, you would find that the sediment got progressively older, and it would probably be layered, sort of in a varve-like fashion. Varves being whenever you have a lake that's fed by glaciers, you get these annual layers that are very distinct and easy to recognize. Well, when they took the drill core samples and looked at them, they saw essentially that the sediment filling the bottoms of those lakes is massive. It's not layered, it's not set, it's not bedded, it's massive, and it was all younger than 14,000 years. So right there, the old model of a gradualistic formation for those lakes doesn't work, because either you had an event where if there was if the bedrock troughs were there, when the melting came, they would have flushed out anything that was there. Although what I'm arguing is that the gorges, the channels themselves, were created by subglacial, highly pressurized subglacial floods that spewed out and inundated the valleys to the south of the lakes. And you actually find the valleys to the south of the lakes just filled with water-laid sediment. And in fact, if you go through the mountains, the hills in the south there, south of the valleys, what you can actually find is on the southern side of the mountains, you'll find huge erosional landslides and effects, giant boulder fields and so forth, that are consistent with water-laid sediment, not glacial-laid sediment. Now, when I had gone and visited the Finger Lakes, I had already been out west visiting very similar features out west, but they're called coulees. And there's one out there called Grand Coulee, for example. I don't know if you've ever heard of the Grand Coulee Dam on the Columbia River. Mm-hmm. It's the largest concrete structure in North America, the Grand Coulee Dam. Well, if you look at Grand Coulee, what you'll see is it's essentially there's a artificial lake in there now because they built a dam in it and they're using it as a reservoir. But if you look on Google Earth and you look at Grand Coulee and then you look at Lake Seneca, you will see that essentially they're identical. Huh. There's two differences though. In Grand Coulee, you've got erosion in basalt bedrock, and you've got a semi-arid climate with no more than about 15 inches of rainfall per year. In western New York, where you are, you've primarily got Devonian shales and roughly, I think, 50 to 60 inches of precipitation a year, which of course creates lots of vegetation. And given the topography, the fact that you see the flow that created the Finger Lakes was to the south, although now the Finger Lakes drain to the north into Lake Ontario. But it's acknowledged by all geologists that now look at it that Grand Coulee was created by giant catastrophic floods, part of what's known as the Missoula Floods. Have you ever heard of the Missoula Floods?
No.
Okay, the Missoula Floods are generally considered to be the largest documented freshwater flows known in the history of the Earth. And they occurred out in the Pacific Northwest, again, around 12 to 13, maybe 14,000 years ago, right in that same window that we're talking about. And we're talking about flows that are so extraordinary that it's difficult to even visualize. And I've taken numerous tours out there because you cannot talk about it or even show photos or slides and get it. You have to actually go to the landscapes themselves to get the impression of the scale of these events that we're talking about. But in the case of Grand Coulee, the water flow that was involved in carving it out was about 350 million cubic feet per second. Well, how much is that? Well, the largest discharge of any river in North America is the Mississippi River, which dumps into the Gulf of Mexico. Its average annual discharge, I think, is around 250,000 cubic feet per second. In its greatest known historical floods, it topped out at just over 1 million cubic feet per second. Well, Grand Coulee was carved by a flow 350 million cubic feet per second. So think about the Mississippi River and its largest historical flood, multiply that flow by 350, and now you've got the flow. Now, of course, the difference, another important difference is when we look at a flood like the Mississippi, it's a low gradient flood. So the water is moving relatively sluggish, maybe 5 to 8 miles an hour. When we look at the floods out of the Pacific Northwest, what we see is water moving at 50 or 60 miles an hour. And so its force is extreme. And so I don't think you'd find a geologist that would declare that you required much more than a couple of weeks to cut Grand Coulee. Grand Coulee it's about 52 miles long. It varies between 1 and 5 miles wide, and it's about 1,000 feet deep. Now, you picture an event that can carve out a canyon 1,000 feet deep, 50 miles long, in a matter of days or a few weeks, and you start getting the idea of the scale of these phenomena.
Wow.
Yeah. Now, again, what I'm going to suggest to you is check this out. Go to Google Earth. Beautiful, great tool for anybody doing this kind of research. Look at the images of the Finger Lakes, and then look at Grand Coulee and note the similarities between the two. I'm arguing that the Finger Lakes, the evidence of the seismic profiles, the deep erosion, the fact that there has so much sediment in it, the fact that the sediment south of the Finger Lakes is clearly water-laid, all of this suggests that you had. Well, and there's one more further piece of evidence, and that is that from the northern end of the lakes up to Lake Ontario, you have one of the spectacular drumlin fields of the planet. And you know what a drumlin is?
No.
A drumlin is the old model is that a drumlin in some uncertain way was shaped by glaciers grinding over the landscape. But if you look at a drumlin from the air, essentially it's an earth form that looks like an inverted boat hull. And there's a team of scientists primarily out of Canada, headed by John Shaw and some of his, Bruce Rains and a number of others, that began back in the 1980s reinterpreting drumlins and saying, wait a second, there's been all of this arguing and discussion and debate as to how glaciers grinding over the landscape would create these elongated, elegant forms that look like inverted boat hulls. They weren't created by glaciers at all. They were created by water flow. Water flowing under tremendous pressure beneath the glaciers. Well, this has been a very controversial idea because, even in science, ideas become entrenched. You get dogmas. People who challenge the dogmas are frequently considered to be heretics. John Shaw is considered to be somewhat of a heretic by proposing that these drumlins are actually proposed by hydraulic means rather than glaciers. His primary criticism has come from those who said, well, the amount of the volume of water that you require couldn't exist as a reservoir beneath the ice. For example, one of the great floods that he documented, he calls the Livingstone Lake event, which essentially gushed out of central Canada, the area of Manitoba and Ontario, gushed down over what is now the Missouri River Valley and would have flowed down the Mississippi. And he estimated the total volume of that flood at 84,000 cubic kilometers. Now, that's just an inconceivable amount of water. His critics said there's no way that you could have that volume of water. See, he didn't provide an explanation for the source of this water. He just said, well, clearly, in the laboratory models and so forth that he and his colleagues did, they were able to reproduce drumlin forms by hydraulic means, by showing that water flowing under pressure could actually shape the material of the ground into these inverted boat hull shapes. And his critics again said, well, the scale of this thing that you're talking about is so great that it would require a reservoir of water that would be impossible to retain under the ice. And he never has really had a suitable answer for that. Of course, from where I'm coming from, and my explanation is that he never had a reservoir, because what we're seeing is the evidence of an instantaneous melting on a large scale, and which allowed water to reach the base of a 1 to 2 mile thick ice sheet and then flow under the ice under tremendous pressure. until it basically burst out in the form of an outburst flood along the southern margins. And so you can basically track these outburst floods all the way across the whole southern margin. You can go to the Midwestern states, from eastern Montana, the North and South Dakota, Minnesota, Wisconsin, coming all the way across, Finger Lakes being a spectacular example up in your area. All the way along the southern margin, you find what could be interpreted as gigantic meltwater floods, sometimes coming what's called supraglacially, meaning off the surface of the glacier, but all other times subglacially, coming from under the glaciers. And while I have not yet visited it, the evidence also is now showing up in the Yukon River and the Mackenzie River and some rivers flowing into the Arctic Ocean, that at the same time these tremendous meltwater floods were coming off the southern margin of the ice sheet, they're also coming off the northern margin of the ice sheet. And you're going to have a guest on, I think, next week, Rand Flemath.
Yes, indeed.
Okay. He talks a lot about pole shifts. I have a different take on pole shifts than his model. But
okay. I was actually just going to ask you about that.
Pole shifts?
Yes.
Well, he goes back to the work of Charles Hapgood, which I find Charles Hapgood was an extremely important player in the revival of catastrophism. And he wrote a couple of books, and Flemath, I think, has based a lot of his work on that of Charles Hapgood. Charles Hapgood basically postulated the idea that the catastrophes were provoked by a shift of the Earth's crust relative to its mantle, probably sliding over the asthenosphere. I looked into that idea, and actually in about 1980 or 81, I procured Charles Hapgood's revision of his Earth-shifting crust called Path of the Pole. And I set out as one of my goals for my free time to read every reference that he had, and it was over 400 of them. And I think I managed to read about most of them. Over the course of the years, I've shifted my thinking into believing that the crustal shifts have taken place, but not to the extent that Hapgood postulated, and that they weren't a trigger of the change, but were a response to the change. And you see, that makes sense from what you would call a rheological standpoint, which is the study of the distribution of mass within the Earth. If you have a gigantic ice sheet piled up on the continent, it depresses the continent in what's called isostatic depression. And in the case of the Great North American Ice Sheet, it depressed regions of Canada sometimes perhaps up to 1,500 feet or more. In fact, I have in my slideshow, I have aerial photographs of the shorelines around Hudson Bay, and you can see that there are shorelines that have been steadily coming up since the ice has been removed. This term isostasy refers to vertical changes in the Earth's crust. So when you have a glacier forming, it depresses the crust. Imagine yourself sitting on a nice big cushy chair. You sit down, and your ass on the chair creates isostatic depression. Okay, when you get up, that's isostatic compensation. So when you get up, the cushion springs back to assume its former shape.
And they're still springing back, aren't they?
They're still springing back, yes, and of course at a much slower rate. But you see, here's the thing: because the Earth is oblate, there's a delicate balance between where, say, a given rock mass is on the surface of the Earth and its latitude and the speed at which it's rotating. Now, if you depress part of the Earth's crust by 1,500 feet, it's no longer at the latitude that would be consistent with that elevation. Likewise, if you raise the land 1,500 feet, it has to compensate somehow. Well, if you raise the land 1,500 feet, think of it this way: it's now out of sync. Because you probably know that the Earth is about 26 miles bigger in diameter through the equator than it is through the pole.
Right.
In round numbers, it's about 7,900 miles through the polar axis and about 7,926 through the equatorial axis. Well, so you've got this distribution of mass that's based upon its latitudinal difference from the equator. So if you are raising a section of land by 1,500 feet, perhaps 2,000 feet, it's no longer at the latitude where it would normally be in balance with the rest of the Earth's mass. So essentially, what I would argue is that once you begin that isostatic adjustment where the land begins raising up again, it's going to have a tendency to want to migrate towards the latitude at which that distance from its center of mass would put it in equilibrium, you see. So, and vice versa. And then bear in mind, too, that as you're melting all of this ice and releasing this tremendous, just hundreds of trillions of tons of weight off of Canada, you're dumping a large amount of that back into the ocean basins. And so the ocean basins are going to have to compensate as well. So as the land is coming up, the ocean basin floor is going to have to sink. And when you factor that in, along with the 400-foot change in sea level, I think that the mid-Atlantic ridge is kind of a hinge point. That's one of the thinnest places on the crust of the Earth is the mid-Atlantic ridge. There is empirical evidence suggesting that there was an enormous subsidence of the Earth's crust centered along the mid-Atlantic ridge that was a consequence of the loading that took place with the melting of the ice and the replacement of the ocean water by coming up 400 feet. There was a commensurate dropping of the ocean floor in an attempt to attain equilibrium. So I tend to look for my Atlantis idea basically in, sort of in effect where Plato said it was, which was west of the Straits of Gibraltar. And we find that there actually is a sunken plateau to the west of the Straits of Gibraltar called the Azores Plateau. And there's empirical evidence along the Azores Plateau that it subsided a great deal at the end of the last ice age. And right now there are huge mountains on the Azores Plateau, and what are now the Azores Islands are only the tips of those mountains.
Huh.
But think about this. If you drop sea level 400 feet, you're going to double the size of these islands. If you also raise the sea level floor by perhaps 1,000 or a couple of thousand feet, many of these islands are actually going to join into a single landmass. And if you also look at during the Ice Age, the route of the Gulf Stream, it basically just turned south about 5 degrees, 7 degrees further south than it now does. So it never really actually reached the British Isles. It turned south just north of the Azores Plateau. So during the Ice Age, regardless of where Atlantis may or may not have been or whether it really existed, during the Ice Age, one of the prime habitable places on the planet would have been some of those mid-Atlantic islands, which were essentially kept relatively warm and tropical by the Gulf Stream.
Huh. Interesting. But his idea of Antarctica being the home of Atlantis is also because Antarctica was ice-free during the last ice age, wasn't it?
Well, the ice in Antarctica has been extremely dynamic, and I think that there were large sections of it that were probably ice-free. I think that idea is controversial. I mean, it goes back to Hapgood. I haven't looked at the latest research, but I think most of the research suggests that the East Antarctic ice cap has been more or less intact for at least several 100,000 years, although the margins of it have fluctuated. I certainly would concur that I think that, there are many surprises that await us as we learn more about Antarctica. Some of the ideas about Antarctica being ice-free come from some of the medieval Portoland maps.
Right.
That seem to show regions of the Antarctica that were ice-free. And I think that that's definitely plausible. There was a period called the Hypsothermal. Immediately on the heels of the end of the Ice Age, there was a period called the Hypsothermal, was also called the climatic optimum, which lasted roughly from about 7,000 to about 9,000 years. All the evidence in hand now suggests that during that climatic optimum, sea levels were higher than now, climate was substantially warmer than now, and it's very possible that during that climatic optimum, that large regions that the ice receded considerably in certain portions of Antarctica, leaving portions that are now, because when I mentioned earlier the Little Ice Age. Well, it appears now that the Little Ice Age was a global cooling. a global cooling like that would probably cause an expansion of the Antarctic ice sheet,
right,
compared to where it was during the hypsothermal. But now the hypsothermal was or climatic optimum was the climate period from, like I said, from about 7 to about 9,000 years ago. This would have been the period that has often been referred to as the period of the goddess, because this is the dating when so many of these goddess effigies show up. It was apparently an interesting time because, come post-Ice Age, it was almost as if the birth of the modern age was so traumatic that then there was a period of 2,000 or 3,000 years of very benign climate. That essentially this would have been the period of climate where, the time during Earth history when it would have been necessary to be fruitful and multiply. Right. Because my suspicion is that the human population most likely crashed just like the rest of the mega mammals.
Yeah. And I always wondered if the texts like that were made almost as a survival guide for the species.
If the what?
If texts like the Old Testament and stuff were written as a survival guide almost.
I think that's a great way to put it. That would be my take on it for sure. I think, and that's one of the reasons why it was considered so important to preserve some of these ancient writings, and why, for example, so much of this kind of information was encoded in the form of architecture. Because where papyrus or paper isn't going to last, architectural stonework is going to be much more durable.
Right.
And so I think by encoding this symbolism into the architectural monuments and so forth. I think that's a great way to put it.
Okay, we're almost out of time. I do have a couple other quick questions for you.
Sure.
First of all, you're on WVBR FM Ithaca. The Last Exit for the Lost is coming up next in about 5 or 10 minutes. One of the things, you have a DVD lecture out, a 2 DVD, 4-hour lecture.
Yes,
go on.
Do. And it covers a lot of this material we've been talking about.
And it does, and it seems like it barely scratches the surface at the same time.
Oh, that's true. It barely scratches the surface. I have 40 years of accumulated research into all of this kind of stuff. I have literally I probably 10,000 or 12,000 slides of features and things that I've taken over the years. But what you got was the first rough copy, the rough draft, if you will, the editor's copy. Now we're coming out with the upgrade, the improved version, and that's going to be available very soon, probably within the next couple of weeks.
Okay.
And so we're pretty pleased with that. Cameron and I have been working through that. We were actually in different states during the first part of the creation of it, and so I was not available. Now we've been going through slide by slide and getting everything real tight and putting in new graphics and new imagery, and a lot of this stuff that we've been talking about, would become is in there. So I have graphs and charts and photographs. I've taken photographs from the ground. I've got aerial photography that I've done. We've gathered together NASA photography so that you can get multiple perspectives on some of these things that we're talking about. I think it's going to be a pretty rich source of information for anybody who finds this kind of subject matter fascinating.
And I have to say, even as a rough draft, the quality of it is fantastic. I've seen a lot of lectures that have been taped, and they don't get good audio sometimes. And what you guys put together, even as a rough draft, is very high quality.
Well, wait till you see the improved version. It's going to be great. And then,
awesome.
We've got. We're also, for those who are interested in the sacred geometry end of it, we're going to be doing a series of online classes coming up where we basically take people through, starting at the very most rudimentary level and taking them through the whole process, sort of in the same format as in the ancient Platonic Academy or in the Pythagorean lodges. Hands-on, and it'll be instruction, and it'll be guided exercises and so forth. And then, of course, we're also always adding new material to the website itself. And there will be a link on the Sacred Geometry website to another website called cosmographicresearch.org, which you can go to, which has a lot of information and photographs regarding the geological and astronomical stuff we've been talking about tonight.
Nice.
And, of course, that's all free.
And that is, what's the website?
Cosmographic Research.
Okay, what's your website so people?
Well, that's it. Cosmographic Research.
Oh, okay. What's the sacred?
And then sacredgeometryinternational.com.
Okay, that was the one I was looking for.
Yeah, and those links are on there. right
Yes.
on the homepage to the others. And then there should be a link to my building website as well.
Okay. And one of the things you talked about, one of the questions I had for you, one of the things you talk about in that lecture is you said that the pyramids could potentially be older than they believe.
Well, yes, perhaps the Great Pyramid is, and I keep open about that. I am convinced by Robert Schoch and John Anthony West's research that the Sphinx is much older than conventional chronologies. When I visited there in 2010, I was able to see for myself and came away completely convinced that was the case. And in fact, I think Robert, in a lot of his public pronouncements, is overly conservative in his estimates as to the date of the Sphinx. To me, I think it has, based on the amount of erosion that we've seen on, not so much on the Sphinx, because they're doing these reconstructions. They're doing they're refacing the Sphinx, which to me is basically just covering up the real message of the Sphinx. But to our advantage, the quarry out of which the blocks were removed, the quarry walls are still there, and they retain the effects of the erosion, which to me has all the earmarks of severe water erosion. It's consistent with evidence that there was also, during the same window of time at the end of the last ice age, extraordinary floods coming down the Nile. Many of the great wadis that open onto the Nile, which are now dry, show evidence of gigantic hydrologic events, gigantic boulder fans at the mouths of the wadis that are only consistent with huge floods. And I think that basically the Sphinx had to have already been there when the flooding occurred in Egypt. And the flooding has been well dated now to, between 12 and 13,000 years.
Right.
And I think that sets a minimum age for the Sphinx. I find these attempts on the part of conventional Egyptologists to dismiss or ignore the geological evidence to be pretty weak, actually.
Yeah. What makes you think the pyramid might be older?
Well, part of it, there's no hard evidence on that. What we got, though, it's a lot of Arabic legends about pre-flood construction. Surus was the name, for example, in one of the Arabic legends. There was a king, Surus, who had a dream, a premonition that there was going to be a great flood. So he built the pyramid as a repository of knowledge. And, of course, that the casing stones have, for the most part, been all stripped off.
Yeah, I was going to ask about that, too.
And when you look at the legends and some of the early accounts, I think they were stripped off in the 1100s. There was an earthquake in northern Egypt that flattened a lot of the buildings in Cairo, and up until that time there had been efforts to try to penetrate the pyramid without success. And because of the fact that the casing stones is a very high grade, very dense limestone, and apparently the joinery was so tight and so close that there was nowhere that one could even get anything in there to try to lever a stone out. So nature came along and did the job for them by this tremendous earthquake. Apparently there was some cracks that opened up in the casing stones that allowed them to then at the same time flattened all the buildings in Cairo. So they at that time began to systematically strip the casing stones, in what I consider the largest act of vandalism in history. But when you refer to the Arabic legends and some of the early travelers' accounts, it says that the entire outside of the pyramid was covered in inscriptions and symbolism. So I find that to be a very intriguing idea. Some of those stones must be in various mosques throughout the city of Cairo. I would have no idea where, but there are also legends, and I can't recall the source of these now because it's been a number of years, that would suggest that travelers, that certain guides pointed out water lines up on the Sphinx, on the pyramid, that they said was a remnant of the floods. So if that was the case, that's purely conjectural. It's not empirical evidence. But I tend to concur with the conventional chronologies towards the rest of the Giza Plateau. I definitely believe that the Sphinx is much older, and I hold open the possibility that the pyramid also, the Great Pyramid of Khufu, was also much older.
Nice. All right. Well, we got to wrap this up. I highly recommend people.
I was just getting started.
I know. I'm pretty sure we could take the next 6 hours very easily. But we'll just have you back on. How's that?
Sounds great to me. It's been fun.
All right. And maybe sometime we can have you live if you come back to Ithaca at some point.
Yeah, I'd love to do that because I've been meaning to get back because there's a lot of things I was not able to see and document when I was up there. And I would love to get back. I love the area. Those gorges, to me, are just enchanted. I imagine you've been in some of them.
Oh, yeah, a lot of them.
Yeah, a lot of them. And we could actually go together, and I could begin pointing out some of the things to you that is unequivocal evidence for catastrophic flood flows.
Well, that would be fantastic.
Yeah, so you can see yourself firsthand.
And your website one more time?
SacredGeometryInternational.com.
Okay.
And cosmographicresearch.org.
All right. And Last Exit for the Lost is up next week, as we mentioned a few minutes ago. We got Rand Flemath on the show. And, www.wheredidtheroadgo.com for everything associated with this show. And we're going to have some Psyche Corporation, as always, take us out. Thanks again, Randall.
Well, thank you, Soraya, for having me on.
Come